Templates in C++. Templates are the foundation of generic programming. Templates are the foundation of generic programming, which involves writing code in a way that is independent of any particular type. It is an independent of any particular type. Okay, so I am writing a general program for general program, and this platform can be utilized by any data type. Okay, for example, we can say that a template is a blueprint or a formula for creating a general class or function. I am creating a blueprint, okay, or I am creating just some formula for a generic class or a function, and that will be accessible by any data type. Normally, if we declare integer a comma b, if we pass only integer data, we can able to add it. But if you are created the template, if you are created the generic programming for addition, and this generic program can be utilized by any of the data. That is, if I passed add 2,3, it will give 5. If I pass add 2.8 and 3.7, it will give the float addition. And if you pass character data type, it will just combine the data type. So based on the data entered into the generic function, it will convert it automatically and it will provide the result. So that is the power of template. Okay, we no need to write each and every function with different parameters, different data type. No need to do that. So template are the foundation of generic programming, which involves writing code in a way that is independent. Independent means you can write any type that will be acceptable. Okay, that is independent of any particular type. A template is a blueprint or formula for creating a generic class or a function. So the syntax and example is, so template is here a keyword. Then how to create a template is template class t. In this t, I am going to use the function add. So this t class, and these are all keywords, okay, that I given in the red color. Okay, class t, add. So add, I am going to use this function. So here t, this is a template t, and here I am going to pass the address of A and address of B. In this template, I am going to pass the address of A and address of B. So on the t result is A plus B. Return result. So in this main function, if you give in the main function void main, if I give as, see, in a void main, I am giving add, I am calling add 5,3, and then I am calling add or cout I am giving, okay, cout add a, 3. So cout add 6.2, 8.3, and here a, b. Okay, so in this case, see, add is a so in this case, add 5,3 is the integer. So it will convert, the control will be transferred here. Okay, the control will be transferred here, and it says the output will be 8. 5 plus 3. It will consider the integer data type. The data, whatever the data passed here, 5 will be considered as an integer and 3 will be considered as integer, and it provides the result 8. In the second statement, I have given that add 6.2, 8.3. So in this case, it will call the template class in the same way, and here now this a value will be considered as 6.2 and b value will be called as an 8.3, and this will be added and provide 14.5. So similarly, see, I didn't define any data type. So that is the meaning of independent of any particular type, which is a template is a foundation of generic programming, and which is writing a code on that is independent of any particular type. That's template. See, and this last statement I have given cout add a comma b. So this here I am passed a character to this a and I passed the b to this character. So the output will be a b. So this is the use of template. You can write a generic programming and it can be utilized for any data type to that program.